Okay, welcome to today. Last lecture we talked about similar polygons and what similar polygons were. We've had an assignment on that. Today we're going to be a little more specific. We're only going to talk about similar triangles and one method to show that they are similar. Okay, there's going to be no formal proofs. We're going to use this method to be able to find lengths of sides. So, okay, similar triangles. What we're going to focus on today is the angle postulate. Okay, the two resources. Only one page on the notes, page 11, which explains what the postulate is, and then the PowerPoint, chapter 7, section 3. Okay, it's a decent one. Okay, so here we go. The postulate itself says, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, remember, similar just talks about either enlarging or shrinking something. Okay, the old movie Honey, I Shrunk the Kids with Rick Moranis. Very good one, folks. Okay, here's what we're looking at. Remember, if those are parallel, we have our parallel line transversal angles. First and foremost, A is common to both triangles. Okay? Transversal to parallels, that means that this is equal to this. There's the two angles right there. We also know this angle is equal to this angle. The reason this works is, if we remember, if we know two angles in a triangle, we know the third. Okay? Because the three of them have to add up to 180, subtract what you know to get the third. If two triangles have two pair of congruent angles, we're subtracting the same number from 180, the answer is going to be the same. Trust me. Okay? So here it is. So, when we're asked to write a similarity statement, match the numbers. Okay? A, B, E, A, C, D. You've matched the equal angles, you've matched the equal angles, and the equal angles. Okay? That's when we're just dealing with what has to be equal. Okay? Now, on the next one, we're also dealing with numbers. Okay? So on this particular one, okay, for the sake of argument here, let's assume we are given a 40-degree angle. Let's start there. Okay? We have a right triangle, and because that's a right angle, that has to be a right angle. Okay? Supplementary, linear pair, perpendicular lines, three good reasons. Fourth, because I said so, right triangle. So here we go. We can fill in the rest of these. Watch how we do it. On this triangle, if this is 40, this is 90, this has to be 50. Okay? Let's look at the overall triangle. 90, 40, this has to be 50. And then in this triangle, if that's 50, that's 90, that has to be 40. I now have three triangles that are similar. Okay? We'll be dealing with this later on, primarily with right triangles and also with a little bit more on the similarity side, because we've just shown that three right triangles that are similar. Okay? And if we remember back to what are parts of right triangle, that's an altitude. That's an altitude. That's an altitude. Ooh, altitudes. So, what we've got. Okay? However you want to do it. Okay? I like to start with the right angles. I think it's easier. So if I go 90, 40, 50, that's how I'm going to stay with each of the triangles to write the similarity statement. So, triangle. JFH. GFJ. GJH. There's the three similar triangles. Okay? That's when we're going to be asked, are they similar? Why are they similar? AA postulate. Match properly and write similarity statements. That's where we're at. Okay, let's go to some problems we're going to see. Okay. So we'll start with these two right here. Okay. Are the following pairs of triangles similar? That's our first question. If they are, write a similarity statement. If not, what more information do you need to prove similarity? Okay, let's look at the first one. I've got two angles, I've got two angles. I can easily find the third angle because 58 and 58 clearly equal. 62 and 60 are not. So, use your math skills or a calculator, it's your choice. Okay? So if I've got 58 plus 62, that means this is going to be 60. Okay? 60 and 58. I now have two similar triangles because I've got the angles that are equal. Maybe a little closer there. Okay? So, however you want to do it. On this one, however I start, I'm just going to go ABC here. Now, since I did it that way, I've got to match the angles from this one. So I went 58, 60. 58, 60. So I've got to go Z, Y, X. Now I have two similar triangles. Okay, down here. Okay, triangles L and M, LQP. We've got to look to see if they are similar. Well, we've got the one common angle there, but it doesn't tell us these are parallel. Okay, so we don't have any more angles. Okay, and we don't have the third side, so we can't check to see if they are in proportion. So this is quite simply no. Okay, we can't prove it. Okay, we would need congruent angles or parallel lines. If we had those, then we could prove that they were similar. But we can't. So we won't, and we'll move on. Our directions for these four problems. Identify the similar triangles, then find each measure. On each of these, you're given sides to find. So remember, when we're finding sides, we don't stop once we find what x equals. Okay, we continue on. So, okay, parallel lines tell me about congruent angles. So that's going to allow me to match things. So that's what I will do here. Okay, I know that this angle has to match this angle, this with this, and we know the verticals are equal. So that tells me that the 18 and the 12 go together. Now watch what I'm going to do here. I've got 18 over 12. I can put the other ratio in right now and solve. However, I find it easier to simplify right now because that does two things. That gives me smaller numbers to multiply and then divide. And once I simplify, I've got my scale factor. Okay, so if I have more than one side to deal with, I've already taken care of it. So here we go. Okay, 6 is the common factor. So 3 over 2, I went to this, so I've got to go this to this. Cross multiply. Solve. Now I'm going to substitute back. It wants LM. So 9 plus 3. Okay. 9 minus 1. Okay. And there's my first problem. Okay. Okay, for number 4 up here. Okay, common, and equal. Okay, so we're good there. However I want to set this up, I have two things that I have to look at. First out, I have this little segment here, and I've got the entire side. I have this segment, this segment. I don't have that entire side. I've got to set up that entire side. Okay? So, for the entire side, I've got to add together. That's x plus 6x, 5 and 2. Okay? So now I can set up common parts to triangles. Here we go. If I want to set up 24 over 8, there, I'm going to do the same thing I did over here. I'm going to simplify first. Okay, and since I went entire side, I've got to do the same. Cross multiply. Okay. So we've got the 2 equals x, or x equals 2, depending on how you want to do it. So what I have to do now is substitute back, and it wants NL, the entire side. Okay? So 7 times 2 is 14. 14 plus 7 is 21. And it wants ML. 6 times 2 is 12. 12 plus 2 is 14. There's my second answer. Okay? Next, we come down here. Okay, once again, I have equal angles because parallel lines exist. So, that and this, okay, we could have gone the other side as well, it doesn't matter. But once again, I have a side of a triangle here. I have a side of a triangle here. This is the side of a triangle. This is not. So, to compare common parts, I've got to combine these to get all of PR. That's going to give me 2x plus 6. Okay, so I'm going to set up 6 over 8. Simplify it. Okay, side over side, side over side. Cross multiply. Okay, solve. Okay, good so far? Now, it wants PS, so 5 plus 7 is 12, and PR. 2 times 5 is 10, plus 6. Okay, there's my two answers there. Okay. That's what I've got going. Okay. So you can find these easier when we're looking back at the photos. Okay. And our last one. Okay, another one where we have vertical angles are equal. Okay. Just mark that right away. And then our parallels. This tells us what goes with what. Okay, so we've got that. 3 over 4. Already simplified. Don't have to work with that. Okay, so I went this over this. I do this over this. Cross multiply. Okay, boom, boom. Substitute. Okay, so we're going to substitute back in. 5 plus 1 is 6. 5 plus 3 is 8. And that's what we've done. Okay, so we have solved all 4 of these. Okay, our last problem, okay, over here, is a word problem. Okay, but it's kind of a cool one. A mailbox casts a shadow, okay, that's 4 foot long. A tree measures 12 feet tall, has an 18-foot shadow. We've got to write a proportion that we can use to solve for the height of the mailbox, and then we're going to actually find it. So, step 1, we need a diagram. No, I'm not an artist. Okay, so okay. We know that's a right angle, even though the tree may be leaning. Okay. Now, we have a mailbox. Okay? And it's got a 4-foot shadow. Okay? And that mailbox is our unknown. Okay, that just tells us that there's mail going out, okay? So if we want to look at this maybe a little differently, look at what we have. two similar triangles. Now we can set up our proportion. I'm going to go height over shadow, height over shadow. Okay? There is the first answer. Okay? Check. Now we're going to solve this. Okay? Once again, like I did over there, I'm going to simplify this first. Okay? Cross multiply and solve. Okay? So here we go. Cross multiplying gets me to here. Simple division, okay? Turn it into a mixed fraction. Now, it does ask for the height, and we have been dealing with feet as far as our measurement. So let's transfer that. 2 2/3, okay, we've already got 2 feet. What's 2/3 of a foot? Well, 2/3 of 12 inches is 8 inches. That's how you do that type of problem. Okay? Questions as usual in class. You'll be doing this assignment Monday and Tuesday. So let's go to work. Thanks for paying attention. I will chat with you soon.